There are four forces that dictate the dynamics of our universe. We all know about gravity, which requires that any two masses be attracted to one another. So technically, I've been attracted to this apple since the day I was born. But because the Earth is more massive, the apple will fall with a greater acceleration towards the Earth than it will towards me. Next, we have the electromagnetic force, which describes the interactions of charged particles, like attraction and repulsion. If you ever played with magnets or watched a thunderstorm, you've probably observed it. The next two forces are the strong force and the weak force. These two forces are short-range forces, meaning that their influence is limited to really short distances. You may have wondered why the protons of the nucleus don't run away. After all, electromagnetism tells us that like charges repel, right? Well, yes, but the strong force is much stronger than electromagnetism and is responsible for holding the constituents of the nucleus together. So now that we have a stable nucleus, we have elements that can form matter, like my apple. But sometimes decay occurs, and this is exactly what the weak force is in charge of. A well-known example of this force at work is beta decay, where a neutron decays into a proton, electron, and anti-electron neutrino. If we rank each of the forces based on their strength, first place will go to the strong force, second place would go to electromagnetism, third place would go to the weak force, and gravity would go in last place. Now that we've described the four forces, let's begin discussing their mediators. Starting off with electromagnetism, we have the photon. This is a massless particle, which means it can travel at the speed of light. To illustrate electrical repulsion kinematically, imagine two electrons each emitting photons and absorbing each other's photons. The electron that emits or throws a photon will experience recoil and move slightly backward, and the electron that absorbs the photon will also move slightly back because it has gained momentum. So as you see, both electrons have moved away. However, it's not all fun and games because not all the mediators work this way, so it's more useful to think of a mediator as a messenger who transmits their message to the other particles. The message could be, come closer, or go away. So we have our bird. If it's a goose, it's what will make it harder to fly, so it won't be able to travel as far. But if we have a lighter bird, it will be able to travel longer distances. But what if we have a massless bird? Then, its range would be unlimited. Hence, electromagnetism is a long-range force, and the strong and weak forces are short-range forces. Now onto the strong force. It has two mediators at two different levels. On the larger scale, the pion mediates interactions amongst nucleons. It is 270 times heavier than an electron on average. But on the smaller scale, gluons are responsible for holding the constituents of the protons and neutrons together. These are called quarks. Next is the weak force. It has three mediators, the W-, the W+, and the Z boson. Just like the strong force, their huge mass limits their range. So to recap, here are each of the forces and their mediators. But wait, what about gravity? Well, particle physicists have theorized the so-called graviton, which is a massless particle, but has yet to be discovered. So it's up to us.